Hello. Okay, we are getting into applications of matrices and determinants. Woohoo! You guys have actually done some already because you have done the word problems with systems, which is technically an application of matrices, but these are a little bit more specific. I'm gonna have you start with a little warm up. If you can find the inverse by hand for number one, then check in the calc, and then number two, solve the systems using matrices by hand. But then you can check in your calculator as well. So pause the video, I'll have some work done out for you. And it's just a quick review of how to find these things. We're gonna do most things in the graphing calculator today, so you won't actually need to do the work by hand, which is cool. All right, guys, check your answers. So for the first one, just a reminder, you find the determinant, put 1 over the determinant, do a little swapperoo with the values in the matrix. Just a heads up that this is another way to show a matrix is the big brackets, but we are used to this way. Then when you multiply through, you end up with this. So this is your inverse. Just a reminder that the only time it's not possible to find the inverse is if your determinant is 0, because then you'd have 1 over 0, which is undefined. For number 2, again, just a reminder of how to do this by hand. You would do the inverse. I didn't even distribute the determinant through because it's a weird number. And then once you multiply through, you end up with 2 and -2. So your coordinates should be 2, -2. Okay, so this is probably one of the nicest applications of matrices, which is to find the area of a triangle. So in the past, we actually used law of cosines for a question like this because it's not a right triangle necessarily. So the faster way to solve these problems is actually just to use matrices and then find the determinant of it. So you can actually do it all in the graphing calculator. The only thing to be careful of is literally it gives you the base times height for the matrix. So this literally represents base times height. So notice that they have the plus or minus 1/2. The only reason why it's plus or minus is because if you get a negative for your determinant, then you have to change it to a positive because obviously area cannot be negative. So let's do an example with this. The order of the coordinates doesn't really matter in terms of what points you're looking at. So just notice that the x value is first, the y value is second, and then the third dimension they replace with 1s. That's because technically you could find the volume of a figure as well, not just the area, if you have that third dimension. But for us, because we're just finding the area, we'll just say that the third dimension is 1 for all of these. So I could start with -2, 2, or I could start with 1, 5. Notice that's in row 2. Or I could start with 6, -1. That's in row 3. So technically you can swap the order of these and it doesn't affect your answer. But what you would want to do is plug that matrix into your graphing calculator. So let's do that. Just a reminder, go to second matrix, go to edit. This is a 3 by 3. And then we're going to type in -2, 2, 1, 1, 5, 1, and 6, -1, 1. Okay, and then to find the determinant of that, remember that's what those vertical bars mean. I can just quit out of that matrix button, go back in to matrix, but go to math. Determinant is that first button, so this should be a quick refresher because you guys just did this. And then go back into matrix to highlight your letter A. Okay, so you end up with a determinant of -33. So what you'd want to multiply by is the -1/2, because that will give you a positive area. Okay, so really you're just dividing that number by 2, and you end up with 16.5. And you could just say units squared because they don't give us units. So again, just to recap, put all your coordinates into a matrix, make the third dimension all 1s, find the determinant. You can do that in your graphing calculator, and then multiply by 1/2 or -1/2, depending on whether you get a positive or negative. Same thing with testing for collinear points. If you forget from geometry what collinear means, it means that they're all on the same line. So it says if the area of a triangle is 0, the points are collinear. Hopefully that makes sense because you literally don't have an area if your area is 0. You have a line. Because if they're not on the same line, the 3 points, if it's something like this instead, it actually creates a triangle. So you could find an area, right? In this case, all you have to do is check whether you get 0 for your determinant once you plug it in. Again, same thing as the triangle. You make your third column all 1s, and you're good to go. So let's check whether the points given here are collinear. So I want to set up my matrix first. So it doesn't matter what order you put the points in as long as you have x first and y after. Okay, and your third dimension is always 1. So 1, 1, 1, 7, 5, 1. And again, plug that into your graphing calculator, find the determinant, and we'll see whether it comes out to 0. Again, if it's 0, they are collinear. If it's not, then it's a triangle, which means you'd have an area. So try that out in your graphing calculator, see if you get 0. All right, guys, hopefully you got -6, which means that they are not collinear. Again, because what that really means is you have an area, which means you're given a triangle. So not collinear. All right, guys, that's all for today. We're going to finish up the rest of the notes tomorrow.